Today we're going to be working on Leetcode question number 212, word search part 2. Given an m cross n board of characters and a list of strings words, return all words on the board. Each word must be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. And the same letter cell may not be used more than once in a word. So if this is the board and these are the words oath, pee, eat and rain, we're gonna be returning eat and oath. Because we can find EAT and OATH. We are gonna just consider the neighboring ones, and it can be any order, like this is eat is going from right to left. This one we're looking for ABCD. We cannot go from A to B and then to C. We can find A, B, D, C, but not A, B, C, D. So that's why it's an empty list. Okay, the way we're gonna be doing it is using basically using a try data structure. But even before that, what we're gonna do is to count for some optimizations and to not get into that time limit exceeded issue in the Leetcode. We're gonna do some optimizations here. So we're gonna count the number of what do you call the characters inside the word, so that when we are looking at a word and we look at some character, we can actually decide right away that whether or not it is possible to have that as like it is possible that that word is gonna become part of the result. So we're gonna have a count, which is a counter function, and then for every single character inside the board, we are gonna count that one. So basically we have a counter. What the counter does is, like, when you put different characters into it, it tells you that how many characters this character, how many occurrences of this particular character are there. So basically we are putting it in, and then we are actually incrementing our count, and we know that how many of those particular characters did occur in that board. Then we're gonna set our try as a map. After that, we're gonna go through every single word in the words. Then we're gonna have a word counter, which is gonna count. So if for that particular word, we're gonna say that how many of those words, basically we're gonna say that we're gonna make a counter of that, and that we're gonna call it word counter. And then for every character in that word counter, what we are going to do is to check whether the the other count we did for every single character, if that is greater than this count, we're gonna say that this is not possible. We're gonna ignore it. FWC of C is greater than the count of C, we're gonna continue. Otherwise, we're gonna set T at the try equals to T, and then for C and W, again every single character, we're going through every single character. If C not in this try T, we're gonna set it T of C equals to an empty empty object. Then we're gonna say that the T is equal to T C. So just like the try, we are actually associating kind of the children of the try model and kind of going forward at the same time. And once we are done with that, in order to say that okay, we are done with every single character into a word, and then we're gonna say that this is like where in the try data structure we say that is word is equal to true or not true. So instead of doing that, we are marking that this is a complete word now. Okay, we're gonna keep doing it for every single word, and this is gonna give us our complete tree. Sorry, the try data structure. Then we're gonna set our result, initialize it to an empty list, and then for I in the range of length of the board, for j in the range of length of the board 0. So we are gonna be traversing through the whole board, and we're gonna be setting self dot we're gonna be calling a function find, which is gonna take board index I, index j, try, and an empty list. And then we're gonna be returning the self dot result. Okay, the last thing we need to do is to implement this find function, which takes self, the board, the whole board, the I, the j, and the try object, and the list which we are sending is the like the prefix. Like okay, we have processed the first these many characters. Like in this example, if we are processing oath, if we have already processed OA and we are just looking for DH, the pre is going to contain that information. Okay, that being said, first of all, if we are like the base condition is going to be, because the way we set up our try object, we don't have is word. What we have is like if this, like if hash in the try, right, then we're gonna delete that, and we know that this is the solution which we should have. So we're gonna have self dot result dot append the pre join, because this is a list of the characters, so we're gonna join it to make the word. So we remove the hash, and this is the base condition where we know that okay, this one does exist. Otherwise, if we are out of bound, the next thing we want to check is the out of bound. If I is less than 0 or I is greater than equal to length of the board, or j is less than 0 or j is greater than equal to length of board 0. If that is the case, we just need to return. We don't want to process it. Okay, now if the board of ij in that try data structure, we have to remember this one because we want to replace it. For the time being, we want to replace it with some character so that we don't keep processing it again and again. So we're gonna say that our temp is equal to the board ij. Then the board, we're gonna set it to ij equals to a $sign. And then we're gonna say that pre dot append that temp we just saved. Okay, then we're just gonna recursively call the same find function with all the different neighbors. Self dot find the board. This time we're gonna go to the right, try with temp, and then pre. Then self dot find board, this time to the one down, try temp pre, self dot find board ij, or you can say I minus 1 and then j. So going to the left, try temp pre board ij minus 1, try temp, and then pre. Once we are done with the recursion, we're gonna set the board character ij back to the temp. Yeah, meaning that we have processed it. Okay, and then what we're gonna do is to first of all we wanna, once we are done with this recursion, because we do wanna just like in the permutations, we have to remove one character from the pre, so that we can actually go back a little and start the recursion again. So we have to pop one character, and the last thing we want to do is that if not try the board I and then j, in that case what we have to do is to delete that try. This is like if we have already like matched one character, and like we have matched before, so nothing is in there, so we just want to delete that node just for the optimization purposes. So that would be try board I and then j. You can't do that. That is correct. Looking good. And it works.